Hi everyone, welcome to Vin's workshop. Today we practice on solving system in three variables. The general idea of solving system in three variables is we have three equations, one, two, and three. So we pick randomly any two pair. Let's say I pick one and two to create the full equation by eliminate one of the variable. I can either cancel out x, y, or z, either one of them. When we create the full equation, we pick two other pair. Let's say I pick 1, 2 already. Now I pick the 2 and 3, the second and third equation to create the fifth by eliminate one variable. But in the fifth equation, you have to eliminate the same variable you did in 4. So let's say if I cancel out z in equation 4, which means I also have to cancel out z in the equation 5. So then we work with 4 and 5 to create the sixth equation. So by this step, you will have like, let's say x equal to something. Let's say x equal to a number a. So after you get on step 6, x equal to 8, we're gonna do is back substitute. We back substitute into either 4 or 5. When you plug into either 4 or 5, we will get the second variable. This time we may have like y equal to the solution for y. Let's say y equal to b. Since you have x, you have y, we can plug in either 1, 2, or 3 to get my z equal to something. Let's say z equal to c, a number. So that's the general idea. That's what we're gonna do. Now let's go ahead and solve this problem. Let's say I want to cancel z. So I will choose the second and third equation because they already opposite coefficient. So I'm gonna write down is solve for equation 2 and 3. So we have x plus 2y plus 2z equal to 9. And the second one is 3x minus 3y minus 2z equal to 1. So as we see that the z variable is opposite coefficient, so when I add two equations together, this one will be cancelled out. Give me 4x minus y equal to 10. 4x minus y equal to 10 is my fourth equation. This is equation number 4. Then I'm in this step so far. Right now we pick two other pair. So let's say solve for, let's say which pair should I use? I'm gonna use the first and the third equation because they opposite side, and to get the same coefficient I just need to multiply the second equation, or in this case the third equation, by 2 to get 4. So I'm gonna solve for 2 and what did it just say, 1 and 3. Equation 1 and 3. So in equation 1 we have 2x plus y plus 4z equal to 12. And the third is 3x minus 3y minus 2z equal to 1. And we just say that we need the same coefficient. So right now it's positive 4, negative 2. So I need to multiply by 2 on the second equation, which will give me, so we keep the first one, I bring down the first equation, 4z equal to 12. The second one will be multiplied by 2, so we have 6x minus 6y minus 4z equal to 2. Now when we add them up, this one, positive 4z, negative 4z, will be cancelled out. Give me ax minus 5y equal to 14. And we name this one as the fifth equation. So we end this step so far. Next one is we solve 4 and 5. Solve for the equation 4 and 5. Okay. Let's say I should put the star in front of every step I'm doing here. Or we should keep track of our work so that you know if you get wrong somewhere, you know how to get back and to fix it. Okay. 4 and 5. So 4 and 5, so we have ax minus 5y equal to 14 and 4x minus y equal to 10. So we try to again use the elimination. I want to, let's say right now is x is easy to cancel out because I see that if I multiply by -2, I will have on the second equation I will have negative ax, which will be easily cancel out with the top part. So multiply our second equation by -2. Then we have the following. So we keep the first equation, ax minus 5y equals 14 stays still, and negative ax minus or positive plus 2y equals to negative 20. Now again, as we see that they are positive a and negative a would be cancelled out when you add them together, was gonna give me negative 3y equal to negative 6. So negative 3y equal to negative 6, I can easily solve for y by divide both sides by negative 3. Then y equal to positive 2. So that is my first unknown, which is on the step I'm giving you, which is step number 6. Now let's say we substitute y equal to 2 into equation 4. So we have substitute y equal to 2 into equation 4. Okay, so in equation 4 we have 4x minus y equal to 10, and my y is 2, so we're gonna plug in y by 2, x minus, in place of y I plug in 2, equal to 10. Then we isolate the x by plus 2 on both sides, so which will give me 4x equal to 12, and we go ahead divide by 4 on both sides. So we have x equal to 3. X equal to 3 is my second unknown. X equal to 3 is the second unknown. So we end the step so far in this one so far. So we're gonna do next is back substitutes into either 1, 2, or 3. So either one of them. Then it looks like the second equation is the easiest because they have all the small numbers. So my next step is substitute y equal to 2, x equals to 3 into the second equation. Okay, so our second equation is x plus 2y plus 2z equal to 9. Then we have x is 3 and y is 2. So we have 3 plus 2 times 2 plus 2z equal to 9. So I skipped some step here because we're gonna add space. 2 times 2 give me 4, plus 3 give me 7, plus 2z equals to 9. And we subtract 7 on both sides. If I subtract 7 on both sides, we're gonna have, let's write down 7 on both sides. Then we have 2z equal to 2. Then divide by 2 on both sides, we will have z equals to 1. And z equals to 1 is my third unknown. So we complete the problem by finding out x, y, and z. But we're not quite done yet. again, it's like the system 2 by 2. You have to write your answer in XY, in this case XYZ order. So this would be 3, 2, 1 is my solution for the system 3 by 3. 3, 2, 1. Alright, now it's your turn. Go ahead, do the cell check. We have the system is x minus y plus z equal to 4, x plus 2y minus z equal to -1, x plus y minus 3z equal to -2. I know that solving the system in 3 variable is quite really hard because it's the long step to get the answer, but as long as you keep in mind the diagram I give you, 1, 2, 3 equation, pick randomly any 2, is not necessary 1 and 2, not necessary 1 and 2 to create 4, and pick 2 new pairs to create the 5th equation, and we work with 4 and 5 to create the 6th. This time we have x, y, or z equal to something. The first unknown, basically you have the first unknown and then back substitute into either 4 or 5th equation to get the second unknown. Then after that, plug in either 1, 2, or 3 to get the third unknown. So, well, I'll let you go ahead and do the problem on your own. You have 5 seconds to pause the video so that you don't see the solution. When you're ready, click place. We will work the problem together. Okay, I believe you have your answer. So here's my answer. We have x is 2, y is -1, and z is 1. That is the answer of this system of linear equation. So let's go ahead and solve this one together. So what we're gonna do is pick randomly 2 equations to cancel out 1 variable. So I'm gonna do is choose the first and second equation because z is already opposite coefficient. So I'm gonna do is solve for 1 and 2. Solve for 1 and 2. So we'll put 1 and 2 together. X minus y plus z equal to 4, and x plus 2y minus z equal to -1. So when we add them together, z will be cancelled out, give me 1x plus 1x give me 2x. -1y plus 2y is positive y equal to 3. This is my 4th equation. Now since I get the 4th equation, now we pick randomly 2 other pairs to cancel out the same variable. So I'm gonna choose 1 and 3 because they already have the opposite side. So solve for 1 and 3. Solve for equation 1 and 3. So we have x minus y plus z equal to 4, and x plus y minus 3z equal to -2. It look like y already opposite side, but we cannot cancel them because we did cancel z before. We have to cancel z again this time, right? So to cancel z, we need the opposite coefficient. So right now is already opposite. I just need the same number. So multiply by 3 for the whole first equation. We will have 3x minus 3y plus 3z equal to 12. And I bring down the second equation. Oops, minus 3z equal to -2. Then when we add them together, we have z will be cancelled out. 3x plus 1x give me 4x. -3y plus 1y give me -2y equal to 12 minus 2 give me 10. And this is my 5th equation. So my next step is solve for 4 and 5. So solve for equation 4 and 5. So equation 4 is 2x plus y equals to 3, and 4x minus 2y equal to 10. We try to eliminate one variable. We can eliminate either x or y, but right now y is already opposite, so I'm gonna eliminate y by multiply the first equation by 2. Then we have 4x plus 2y equal to 6, and bring down the second equation equal to 10. Okay. When we add them up, y will be cancelled out, and 4x plus 4x give me ax equals to 16. So ax equals to 16. We can isolate the x by divide by 8 on both sides. Then x will be equal to 2, and that is my first unknown. X is equal to 2 is my first unknown. Now we do back substitution. So we are on number 6 so far. We are on equation 6. Back substitution into either 4 or 5. So look like 4 is the easier, a simpler equation to plug in and calculate for y. So I'm going to do is substitute x equal to 2 into the fourth equation. Okay, so we have what? 2x plus y equals to 3, and my x is 2, so we have 2, plug in 2 for x, plus y equals to 3, so we have 4 plus y equals to 3, subtract 4 on both sides, we have y equal to -1 is my second unknown. Now my last step, so we in this one so far. Now we back substitution to either 1, 2, or 3. Let's say substitute x equal to 2, y equal to -1 into my first equation. So we have x minus y plus z equal to 4. X will be replaced by 2 and y will be replaced by -1. Then we have 2 minus -1 plus z equal to 4, which means 2 plus 1 plus z equal to 4. Combine line term here give me 3 plus z equal to 4. Then we isolate the z by subtract 3 on both sides. Then z equal to 1, and that is my third unknown. And again, don't forget the last step. Write your final answer in x and y order. So we have, let's say I write here, we have x is 2, y is -1, and z is 1. So that is the final answer, which match with the one I just tell you before. There are two more examples I want to go over with you. So the first example is 2x plus y minus 3z equal to -3, 3x minus 2y plus 4z equal to 2, and 4x plus 2y minus 6z equal to -7. As we practiced two examples already, actually one example, one subject, now you have some idea how to solve this one. So I just go ahead and solve this one. So I pick out the first and the third equation, solve for 1 and third. the first and the third equation. So we have 2x plus y minus 3z equal to negative 3, and 4x plus 2y minus 6z equal to negative 7. And I want to cancel out z. Since this one has negative 3 and the one is negative 6, we know that the least common multiple between 3 and 6 is 6. So I'm going to multiply the first equation by 2, so that 2 times 3 gives me 6. But right now they have the same side, so I also want their opposite side, so I'm going to multiply by negative 2. Then we will have negative 4x minus 2y plus 6z equal to positive 6, so equal to 6, and 4x plus 2y minus 6z equal to negative 7. Okay, so when we add them together, we have z will be cancelled out, but also x cancel out and y cancel out. Give me 0 equal to 6 at negative 7, give me negative 1. But 0 not equal to negative 1, this is the false statement. So when we have the false statement, the final answer is no solution. Okay. Now let's go over the last example. So we have 3x minus 2y plus z equal to negative 1, 2x plus y minus z equal to 5, 5x minus y equal to 4. So as we see in the third equation, z is missing. So let's remind how to solve a system linear equation with 3 equations. So we have first equation, second equation, and the third equation. The concept is to randomly any 2 equations to eliminate one variable and create the 4 equation. And we pick 2 other ones to create the 5th equation, but we have to cancel out the same variable we cancel out at number 4 and work with 4 and 5 to get my solution of the first unknown, which is 6. So this case will be let's say x equal to a, then we back substitute into either 4 or 5 to get the second unknown, which is let's say y equal to b, and back substitute into 1, 2, or 3, either one of them, to get the last unknown, which is z, let's say is equal number c. So as we see in the system, in the third equation, z already missing, which means if I want to save my step solving, I can name this one as the 4th equation because we have one variable less. So then I can work with 1 and 2 and eliminate z because z is missing on equation 4. So I will go ahead and do that. Solve for equation 1 and 2. Equation 1 and 2. Then we have the following. 3x minus 2y plus z equal to negative 1, and 2x plus y minus z equal to 5. Since z already has the opposite coefficient, then when we add them, z will be cancelled out, which left me with 5x minus y equals to 4, and this one is my 5th equation. Then we solve 4 and 5 together. Solve for equation 4 and 5. So we have 5x minus y equals to 4 for equation 4, and 5x minus y equals to 4 for equation 5. We have 2 equations exactly the same form, but we have to follow the concept, eliminate one of the variable. So I'm going to do is multiply the first equation by negative 1. Then we will have negative 5x minus plus y equal to -4, and bring over the second equation, so 5x minus y equal to 4. Then when we add them together, 5x will be cancelled out, also y cancel out, give me 0 equal to 4 and 4 will be cancelled out, give me another 0. 0 equal to 0, that's the true statement. So my final answer will be infinitely many solution. Okay. So you have seen all four example. Now is the time for you to practice. So go ahead, I have 5 problems for you to practice on. If you get stuck, you can go back to for example and practice more, understand them. Um, okay, you can pause you have 5 seconds to pause the video, then I will post the answer. Alright, here's the answer. Problem 1 is 2, 1, 1. Problem 2, 4, -2, 1. Problem 3, no solution. Problem 4, dependence. And problem 5, 2, -3, and 5. I hope we have all correct answer. Thanks everyone for watching.